Hi guys, so lastly we'll be doing the distributive law. I believe that's the last one. Yeah. So 3, or I don't know what I've been using. Distributive law. Yeah. And okay, so don't forget that this column here is for convolution as usual, and the one here is correlation. You don't really have to put it in this tabular form like I do. You could do it any other way. I mean, in as much as your answer is right, but this is how it works for me. So for distributive law, the law is that this should be equal to x, y plus x, z. Yeah. So we're going to confirm if x, y plus x is the same as x into bracket y plus z. Okay, so generally, okay, before I put this line, generally, your y plus z, yeah, is equal to our initial value of y has always been minus 1, 2, yeah, plus, and the z has always been 1, 1, right? So what we're saying here is that minus 1 plus 1, of course, is 0, and 2 plus 1 is 3. So generally y plus x will be equal to, that means y plus x, our value for y plus x is 0, 3, right? So if we are coming back to convolution now and correlation, our x is 2, 1. Yeah, you could check back the question again, but our x is 2, 1. So we're going to write 2, 1, and then our y plus z is 0, 3. And don't forget that for convolution, you time reverse one of the signals. So you have 3, 0. And then we'll put our values here. So 2 times 0 is 0, 3, 0. 2 times 3 is 6, plus 0. Yeah, and then 3, 0. And then you have 360. Yeah. And, okay, I'm trying to scroll down. So that's, so x, y plus z is equal to 0, 6, 3. Yeah. So now let's solve for xy plus xz. Now our values for xy, okay, sorry. So our value for xy initially is our value for xy is minus 2, 3, 2, and xc is 2, 3, 1. So calm down. What's going on? So xy is for convolution, xy is minus 2, 3, 2, and xz is equal to xz 2, 3, 1. Yeah, so xy plus xz is equal to minus 2 plus 2, that's 0. 3 plus 3, that's 6. 2 plus 1, 3. So we can see that distributive law is obeyed for this case. because the values are the same here and here for this. Yeah, so let's do for correlation. So for correlation, yeah, same. Our y plus z is 0, 3, and our x is still 2, 1. So we're going to put 2, 1, and we're going to put 0, 3. You know, here we don't time reverse anything, so 3 times 2 is 6, 0, 3, 3 times 1, 0, 3, and you have this. So x into bracket y plus z is equals to 6, 3, 0. So solving for xy plus xz under correlation, xy is 4, 0, minus 1, and xz is 2, 3, 1, right? So if we are hardening xy plus xz is equal to 4 plus 2, 6, 0 plus 3, 3, minus 1 plus 1, 0. So you can see that even also correlation also obeys distributive law. So convolution and correlation obey distributive law. So all together, assuming I put a table, yeah, altogether, assuming I put a table and I say convolution, correlation, is that how to spell correlation? No, I think it's 1L. And I say 1, commutative law, okay, I'm going to erase this. So for commutative law, convolution obeys, but correlation doesn't. I'll say number 2, associative law. Convolution obeys and correlation obeys too. Then distributive law. Convolution obeys and correlation obeys. So let's say I use, just for picture's sake, so that this is a big no while every other is green. Let me increase the thickness of this. I'm allowed to catch some fun, right? Sorry, I just want to catch some fun. So guys, I hope this was helpful for everyone. I mean, it's okay for you to ask questions, and if I made any mistake anywhere, I'm so sorry. You can call my attention to it. We're here to learn together. Have a good evening, guys.